Chapter 13. Chapter 13. Okay, chapter 13 was our chapter on the physical natures of matter. You know, it talks about particles and things like that. Okay, but it's only a midterm, so I can't talk on a lot of things about it. But you need to know, it's going to be a test question. You need to know Avogadro's number, right? So know Avogadro's number. Know Avogadro's number. Anybody know what Avogadro's number is?
6.022 times
6.022 times 10 to the 23rd of anything. That is Avogadro's number.
It's a mole.
A second problem, which is very similar to this, okay, I'm going to ask you just like I did on the quiz, instead of the weight of an atom, I'm going to give you a mass of a particular atom. So if I told you I want the mass of, let's say, a lithium atom, okay, what's the mass of a lithium atom? Then what you would do is look up on the periodic table for the AMU of lithium would be 7. But that, remember, this is relative scale. If I had 1 mole, this would be 7 grams, and 1 mole represents 6.022 times 10 to the 23rd. So if you divide the 7 by Avogadro's number, you have the mass of 1 lithium atom, yeah?
Okay, so so the mass of the lithium on the periodic table, it's the bottom number, right?
That
The
is
one that's
correct.
has the decimal point at the bottom.
That's correct.
And it would be 7 for lithium, and then you just divide it
By
by.
Avogadro's number.
Okay,
All right?
I'm new to chemistry.
Yeah, that's going to be new for you, but that's all you're going to have to know about that. Okay, in this chapter also, what you're going to have to learn to do, you are going to have the phase diagram, you know, it's going to look, you know, something like this. You have a phase diagram. You are just going to label the phases that are here, okay, and certain points. So, what would we call this phase right here? What is this on a phase diagram?
Gas.
Solid.
Yeah, that's,
This is not gas, gas is over here.
That's
And you gotta
solid.
put pressure, temperature. Okay, so
It's been a while.
this is liquid, yeah? I mean solid, yes? Solid is here. Solid. Okay, what's in here?
What,
Liquid.
Liquid. Okay? What is here?
Yeah.
Gas. Okay? And what's this point here called? Triple point. Okay, so this is the triple point. Yeah, so we know all that. Okay, we need to know some of the processes, yes? So like if I cross this line here, what process is happening?
Condensation. Wait, no, solid, not gas.
What is
Melting.
melting?
melting.
Okay, what process is going reverse?
No,
Freezing?
Freezing. Boy, we're having a difficult answer.
I'm tired.
What if I
Yeah.
cross here from here? This way.
Oh,
Um,
no.
Vaporization?
It's
Vaporization. What's this way?
Same
condensation?
thing.
Condensation.
condensation.
And what's going across here?
Sublimation.
And it's sublimation going back that way. Okay, now, you also need to know if the solid floats on its liquid. In this picture, does the solid float on its liquid?
Oh my
No.
gosh, I'm so
Huh?
good. Jarvis Perkins.
No, it does
No.
not.
It's if the line goes backwards.
Yeah.
This has to go backwards like that,
Okay.
and then it will float on its liquid, okay?
Okay.
So just make sure that if you see that, you go, oh, it's gonna float on its liquid,
All right.
okay?
Hold on.
Everybody understand how to read a phase diagram? It should be clear. When you get to this spot, you should be able to go, boom, 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 I know how to do that. Okay? And like I said, I don't have time to make complicated problems. So they're all gonna be straightforward. I can't, in physics, you're just gonna have the formula, and then if you have the formula, you should be able to plug it in. And you'll see on when we do the final problem in this chapter, chapter 13, you are going to have to calculate the stress and the strain. So the last thing in this chapter we talked about was the stress is going to be the force divided by the area. That's the cross-sectional area. Cross-section and the strain is the change in length over the original length. So I'm not gonna make you do a modulus problem. You're just gonna have two separate problems, one to calculate the stress and one to calculate the strain. The stress is the force divided by the area, and make sure you know, like for a square, the area is length times width. And when you do the strain, when you put the force on it, the object might compress in. You want the change in length divided by the original length. And then that'll give you the strain. That's all you have to work on. You won't have to do anything else about that problem. Okay, any question on that? We good so far?
Mm-hmm.
Okay.